On the left, we have a trinomial where the leading coefficient is not equal to 1, and there is no greatest common factor that we can pull out. The way I usually teach this to my students is to take the leading coefficient, multiply it by the last term, that would give us negative 21, and place that in the box. And now try to find two factors that multiply to negative 21 and add to positive 4. So if we do a sign analysis, we know that the signs of the two factors have to be different. Otherwise, they would multiply to a positive number that's in the box instead of what we have, a negative. Now, when the factors are different signs, you look for two factors that are this far apart, 4 apart, and they would be none other than 7 and 3. And the 7 will be the positive factor because our middle term is positive, and these two have to sum to a positive middle term. The next move is to take this middle term, positive 4x, and rewrite it creatively, meaning we're going to rewrite 4x as 7x minus 3x. Perfectly legal to do that because 7x minus x is 4x. Now we're going to do factor by grouping. Now, I think it's going to be easier to pair the minus 3x with the 3x squared. So we're going to have 3x squared minus 3x over here, and then we're going to pair the 7x with the negative 7 over here. At this point, we factor out the greatest common factor, which would be 3x, and that would leave x minus 1 inside. I always double check by redistributing in my head, and indeed we get 3x squared minus 3x. And as soon as we get this in the parentheses, we copy and paste that over here, and we figure out what has to be in front to distribute and yield the 7x minus 7, and that is none other than positive 7. We then pull out the greatest common factor, that is x minus 1, and you are left with the other factor of 3x plus 7, and that is your final answer. Let's now factor the same trinomial using a different method. So we are going to multiply the 3 by the negative 7 and get negative 21, but now we're going to rewrite the expression without the leading coefficient, and we're going to bring the negative 21 down below. Now folks, this is easy to factor. All right, this is going to be a plus and a minus because we have a minus 21, and we're going to have a plus 7 and a minus 3. And double check your work, we're going to get x squared plus 4x minus 21. Now, folks, we bring this original 3 back into the problem. And what we do is we divide the second term by the 3, as so. Here, when you have x plus 7 over 3, you simplify it by multiplying both terms by the 3. You're going to have 3x here. You multiply 7/3 by 3, and you're going to end up with plus 7. And here, this evaluates to an integer, namely x minus 1, so you leave it as is. You don't need to take this 3 and multiply it by the x. And here we get the same answer in perhaps a more expeditious fashion. As we'll see in this next problem, this method works even when you insert a second variable. So here again, we have a leading coefficient that is not equal to 1, and there is no GCF to pull out. We're going to take this 5, and we're going to multiply the final term by the 5, and that's going to give us 20y squared. We are now going to rewrite the expression without that leading coefficient, and that's going to yield 21 plus xy, and we're going to bring this in as our last term. Now we're going to factor this, which is not too bad. We know we're going to have x here and x here. We have to have two factors that will multiply to 20y squared, but give you this middle term. That's going to be none other than plus 20y and plus 1y. We are then going to bring this original 5 that we dropped out, and we're going to use that to divide the second term in both expressions. Here, we're going to get an integer, x plus 4y. And by integer, I mean that 4 is an integer. We leave it as is. But here, on the second factor, we have this 5 here. We're going to multiply both the first term and the second term by 5. And that's going to yield a 5x plus y, because these 5's will cancel out. Let's double check and FOIL this in our head. We're going to get 5x squared plus 20xy plus 1xy plus 4y squared. In our next example, we're going to take this 2, multiply the positive 27 to get positive 54. Then we're going to leave the 2 out as we rewrite the expression. We're going to bring the positive 54 in. We're now going to go ahead and factor that as x plus 3 and x plus 18. We're now going to reintroduce the 2. We're going to divide that by 2 and this by 2. This is an integer, so we don't need to do anything else. Here, we're going to multiply both the first term and the second term by that 2. Here, we're going to get 2x. Here, the 2's are going to cancel out, and we're going to get 3. And this is our final answer. Quickly checking the FOIL, we're going to get 2x squared plus 3x plus 18x plus 27. We have a trinomial where the leading coefficient is not equal to 1, and there is no GCF to pull out. We're going to take the leading coefficient, we're going to multiply the final term, we're going to get plus 72. We're going to rewrite the expression without the leading coefficient, and we're going to drop the positive 72 down below. We're then going to factor this, which is relatively easy, x plus 9, x plus 8. Then, folks, we're going to reintroduce this 12. We're going to divide the second term here by 12 and the second term here by 12. Here, we're going to get 9 over 12. The way I like to break down 9 over 12 is breaking it down to 3 times 3. 12 would be 3 times 4. The 3's cancel out, so we're going to end up with x plus 3 over 4 for our first factor. And then breaking down 8 over 12 in similar fashion, we're going to do 2 times 4 and 2 times 6. And then we're going to do 2 times 2 and 2 times 3. And we're going to end up with x plus 2/3. Now, neither of these are integers, so we're going to multiply on the first factor. We're going to take each term and multiply it by 4. 4 times x is 4x. 4 times 3 over 4, the 4's cancel out. Here, we're going to multiply that by 3 and that by 3. We're going to end up with 3x plus 2 because these 3's will cancel out. Quickly checking, if we FOIL, 12x squared plus 9x plus 8x is 17x, and 3 times 2 is 6. In our last example, again, leading coefficient not equal to 1 and no greatest common factor. We're going to take this 6, multiply it by the negative 4, we're going to get negative 24. We're going to rewrite the expression without the leading coefficient of 6, and we're going to drop this in. We are then going to factor this relatively easy to factor trinomial. We're going to have a plus and a minus. The minus is going to be bigger, and 8 times 3 is 24. Now we're going to reintroduce the 6. We're going to take this 6 and we're going to divide it as so on the second term of each of the factor. This is going to reduce to x plus 1/2. And here, breaking down 8 over 6, we're going to have 2 times 4 over 2 times 3. The 2's cancel out. So here we're going to have x minus 4 over 3. Because neither of these are integers, we're now going to simplify them by taking this 2 and multiplying that term and that term by 2. We're going to end up with 2x plus 1 here. Here we're going to multiply this term and that term by 3, and we're going to have 3x minus 4. A quick check, FOIL, we're going to get 6x squared plus 3x minus 8x gives us negative 5x, and then the final two terms give us negative 4.